Okay, in this video we are going to understand a bit more about the laws of exponents. So let's see law 1. Let's say, for example, you have any number 3, okay, and you are given 3 to the power 3 into 3 to the power 2. Now if suppose you calculate this, you write this as 3 into 3 into 3 into 3 into 3. But what we have learned earlier is that if a number is multiplied by itself n number of times, then you can also write it as 3 to the power 5, because 3 is being multiplied by itself 5 number of times. Now, there is one important thing, or one interesting thing. If you notice here, 5 is equal to the sum of 3 and 2. So 3 plus 2 is equal to 5. Or you can also write this as 3 to the power 3 plus 2. Right? Let's take another example. Suppose you have x cubed into x to the power 4. So x cubed can be written as x into x into x 3 times into x into x into x into x. So this is 4 times and this is 3 times. Well, but interestingly, because here x is the base and it is multiplying itself how many times? 7 times. So you can also write this as x to the power 7. Well, again what I note here is something similar, which is that 7 is equal to the sum of 3 plus 4. So you can write this as x to the power 3 plus 4. Now if you generalize this particular thought, then it just becomes like this, that you can write that, let's say you have for any base a, okay, suppose your base is a to the power m plus a, sorry, not plus, when multiplied by a to the power n is equal to a to the power m plus n. The only thing is that this a is not equal to 0, okay, and m and n have to be whole numbers. These powers can't be negative. It has to be whole numbers, which means 0, 1, 2, so on. Can't be minus 1, minus 2, minus 3, etc. So this is basically the rule, that for any number a which is not equal to 0, to the power m into a to the power n is equal to a to the power m plus n. Let us look at the second law of exponent, which is relating to division. Suppose you were told to divide 2 to the power 6 by 2 to the power 3. Okay, how would you resolve this? 2, 2, 3, 4, 5, 6. Divided by 2 to the power 3, so I multiply 2 into 1 into 2. So this and this gets knocked off with this and this. Or what is left is 2 into 2 into 2, or 2 to the power 3. But what do I note here? This 3 is equal to 6 minus 3, which is the power of the first and the second number. Or I can also write this as 2 to the power 6 minus 3 in the same order. First the numerator, then the denominator. Let's try this out for some. X to the power 5 divided by x to the power 3. So you get 1, 2, 3, 4, 5. And 1, 2, and 3. So 1, 2, 3 go, 1, 2, 3 goes. This becomes x squared, which is again x to the power 5 minus 3. Where is 5 coming from? The first power, 3 is the second power. Okay? So therefore, we generalize that for a non-zero integer, which can be anything, let's say x to the power m when divided by x to the power n is always equal to x to the power m minus n. Right?